I'd love to start with a little bit of like a level set and some definitions. Abacus has created a whole library of content, which is very interesting. We'll talk about this. So like I know you cover those topics. So for the broad audience here that may not know all the details, can we start with an actual definition of neural networks and what those actually do, what they're good at and not so good at?
Okay, so at its very, very basic level, think of neural networks as literally a bunch of different kind of nodes. Think of a graph, and and in the graph there's going to be inputs. So inputs into the graph, and then there's outputs. And imagine that there is a bunch of data. Take a very a simple use case. The best example use case that I like giving people is the use case of cat versus no cat. So imagine if you had 1,000 images, and in those 1,000 images, there were 500 which had a cat and 500 which didn't have a cat. And what you're going to be doing is training a neural network to detect if there's a cat or not. And the way you would do that is you would input the image. And from the neural, from that input, you want to be able to get an output, and the output is a simple output, which is cat versus no cat. So the input can be, the image in a mathematical form. And what you're doing is at all times, you're taking this mathematical vector and you're transforming it. And you're transforming it in different ways. And there's 2 ways you can transform it using something called a weight or something called a bias. So just think of that as a multiplicative factor of that image or an additive factor. And using those transformations, you get to like an output, which is cat or no cat. And so you have this graph network, and you have these weights and biases. Think of it as parameters in a function. And all you're doing is fitting that function. And so that's a neural net. It's just like, think of it as a very generic universal function that you're fitting with the weights and biases of each of those nodes in the graph. And once you fit that, you now have a model which, given a new image, the 1,001st image, will take that vector of that image and try to like predict whether it has a cat or not. So what it's doing essentially is it's learning the mathematical representation of that image and mathematical representation of the cat specifically, if that makes sense at a very abstract level.
Great. Do you want to talk about the different types of learning, supervised versus unsupervised?
Yeah, and so neural nets have become really popular over the last few years. And the reason why they've become really popular is they are very effective at basically solving pretty much all problems. So if you're looking at, Dave before me spoke about, I think, 80 different machine learning problems that Pinterest is solving, right? And a lot of those problems have to do with images. And before 2012, these problems were very hard to solve. What happened in 2012 is a bunch of people came up with a neural net called AlexNet, which really was good at processing these images and solving for different types of image classification problems. So kind of determining whether they're cats or, different objects in the image. And so basically, once they figured that out, they started realizing that there could be a whole class of problems which neural nets could solve. And at a very global level, think of it as, 3 types: supervised and unsupervised, and let's just say semi-supervised learning. Supervised learning is what you see every day. This is what you see used in Pinterest. This is what you see used in Google. And basically, it's nothing more than getting labeled data and using that labeled data to train a neural net. So you're telling the neural net, this is an image which has cats. You could also tell the neural net, this is a video which has a person moving. That's what happens in an AV company. They actually train with loads and loads of data, which they get by recording as they drive, and then like actually labeling each and every single piece of that video with like pedestrians and stuff like that, right? So that's labeled data, and then you're training that data, and that's supervised learning. The other extreme of this, and the magical extreme of this, is what we call unsupervised learning, where you take a bunch of data and just give it to a model, and that model tries to learn patterns in that data. At its very simplest, think of like taking a bunch of data and clustering data points which are together, and that's unsupervised learning because you're not teaching it anything. and everything in between, where you have some labeled data and which you can learn, which you can learn from, and then use that some labeled data to actually learn from data which is not labeled, is what you would call semi-supervised learning. So if you think about that, those two extremes, where there are tons of models in production are in supervised learning. Unsupervised learning is kind of coming of age. Things like anomaly detection is unsupervised learning, if that makes sense.
And you mentioned examples with videos, which qualifies, as well as document and sounds, that qualifies as unstructured data. But deep learning can be used on tabular data as well, right? What are some examples and some use cases for tabular data?
Yeah, I mean, that's my favorite topic. If you guys look at Abacus, you will see that our first focus was all on tabular data. And the reason we focused on tabular data and why tabular data is actually pretty effective with deep learning is one, because every company has multiple different examples or machine learning models that they want to develop using tabular data. At its most basic level, we have something called predictive modeling. Predictive modeling is very similar to finding a variable, which is what we call a dependent variable based on other independent variables. Let me give you a concrete use case. If you go and look for a home on Zillow or Redfin, you have something called the house property price, right? Estimate, the Z estimate. I'm sure everyone's seen this. The Z estimate comes because they have a machine learning model, which is a predictive model, which is using all kinds of properties like, say, bedrooms, bathrooms, square footage, neighborhood, location, and whatnot, and trying to determine the price of the house based on recent homes which have sold, with those attributes. So it's learning constantly based on recent sales, and then trying to predict based on the attributes of your home, what the price would be, right? That's a predictive model. And these predictive models, there are very many methods you can use to find these predictive models. So conventionally, people use things like gradient boosted trees or tree-based algorithms, classical algorithms. Of late, there is a big rise in using neural nets. So if you look at a company like Google or Facebook, almost all of their models, like 95% of their models, are neural net based. Why? Because neural nets actually do really well with high dimensional tabular data. So in the case of these houses, they do really well if you have 50 plus columns. And the more columns you have, the better they do. Second aspect of this is neural nets will actually look at the structured, unstructured pieces of the data. Let's take the example of the houses. What if I can put in the description of the house to also enhance the price? So clearly I could say, hey, I have like a huge barn door or a pool house in my house, right? That may be just in the description. And the neural net can pick up that every time there's a pool house, there is like maybe a 50K extra that you price the house at. A classical machine learning model want to do that for you. So here the neural net is looking at the language data, understanding it, and helping you parse that data. Take one more example. If you have a sequence of events, so if a particular event is followed by another event, take, for example, if you're doing a lead scoring model. So you're scoring all your incoming marketing leads, and you want to be able to score the leads which are going to become customers as high, and leads which are not going to be customers as low. The neural nets will do a much better job than a classical model, because the neural nets will look at the sequence of what the customer did. For example, if they've just taken a webinar or they came to a webinar, they're much more likely to convert than if they've taken a webinar 5 months ago, and then they maybe clicked on an ad, and then they kind of dropped off, right? And so those are the two big reasons why neural nets are super useful in tabular data as well.
Great. Let's talk about Abacus. So a big part of the vision and the idea, as I understand it, is really to democratize access to what you just described. Tell us about the platform and what the company does.
Yeah, so we believe we're unique in the sense that we want to do what is called autonomous AI. And what do I mean by that? What I mean by that is we want to ideally convert your data as is. So let's assume you're using a Redshift or a Snowflake or what have you. There's a bunch of data sitting there. It's coming in on a regular basis. We want to ideally take your data and be able to convert it into intelligence. And what that means is at enterprise scale. What that means is we want to be able to take a use case, say lead scoring. Assume that your data is in 4 or 5 different places. We want to be able to connect to these data sources, set up your data pipelines, do automated data transformations and data wrangling and data processing. And once your data is ready for consumption by a model, We want to be able to find the right neural net based on your use case and your data set, and create the best neural net that is possible with your data, and then help you deploy that neural net into production. And then once it's in production, you want to ideally be able to retrain that model, keep that model running, and keep that in production over a long time. And that's kind of what Abacus does, that end-to-end of reading your data, processing your data, managing those data transformations, creating that model, and then putting that model in production and continuously retraining it and learning in a way so that your model becomes more and more smarter over time. And that's what we are calling end-to-end autonomous AI. And that's what Abacus does. This is not to be confused with auto ML, which is just creating.
I was about to ask. This is great.
This is not to be confused with auto ML, which has been around. I think Dave actually mentioned this too. It's been a hot topic for a long time, right? How do I build machine learning systems easily with less code, no code, and put it into production? Auto ML is one piece of this, which is finding the right model based on your data. We actually automate the whole end-to-end, and most of the chunk of the work we do is in the data processing. The data processing, wrangling, management, which, if you guys are data scientists, at least in the audience, that that's a pain. And that's the most problematic thing. It's called Data Driven NYC, I guess, for a reason.
And how does it work behind the scenes? Presumably, you using different sort of open source frameworks, and you build a glue around them to have them all work together. Is that the right way to think about it?
That's absolutely right. I mean, when I saw Dave explain all of those pieces in the Pinterest ML system, we literally have equivalent pieces in our service, right? For all of those pieces, all the way from workflow orchestration to data transformations and so on. So yeah, so we are similar. We use some version of Kafka internally, Kubernetes, Spark, Redis. So pretty much everything that I'm talking about here is an open source vendor. So yeah, it is a bunch of these different tools pulled together. TensorFlow, of course. We also have written a bunch of stuff ourselves. Most of our engineering team, actually one of our co-founders is the founder of BigQuery. So there is a very sophisticated data engine that has been written, which can process data at scale. Things like merging, streaming and batch data sets together, transforming that data, making it available in real time. These are some hard problems, which we solve.
Very good. And what are you building next? What is the roadmap? You're still a young startup, so I imagine like you're releasing a lot of stuff at a rapid cadence. What's on the docket for this coming year?
Sure. I mean, when I say what I say, a lot of people are incredulous, to be honest, because they're like, is this really possible to do? So I would say in terms of like where we are in our current product evolution on a 0 to 10 scale, we're around 7.5, meaning we're still having to add a lot of stuff because we learn as we go, as we get new customers, and there's a lot of demand for our service right now. And so, as we get new customers, we want to make sure that the customer is actually getting what we are talking about, which is this end-to-end autonomous AI. So a large part of our, work is focused on making that happen. Things like, making sure the data transformations are robust and so on. Having said that, the key other focus we have for this year is releasing a whole bunch of use cases beyond structured data and unsupervised learning, which we just released late last year, which was around anomaly detection. This next quarter, we're going to be releasing a whole bunch of language use cases, support for language, and Q3, Q4 is support for vision, so support for image use cases.
Great. Who's an ideal customer for the platform? Is that like a Fortune 1000 company that doesn't have the engineering resources? Is that a startup? Like, who's the ideal customer?
So we have a bunch of, I would say, startups and medium-sized companies. So we have, I would say, two classes of ideal customers. One is the startup, the medium-sized company who basically wants to go, right? They have like 7 different ML use cases. They may have anywhere between 2 to 5 data scientists, sometimes 0. So let's say 0 to 5 data scientists, and they want to get things in production. What we've seen all the time is, I'll give you a classic example of this. This is a medium-sized company, not really a startup. It's a company called USIC LLC. I'm picking this one because they're the 811 company. When you call them every time you want to dig somewhere. because they have to come and mark exactly where a particular, utility is, so that you don't dig it and harm the utility. They're a pretty large company. I think they're about 500 plus employees. They have a ton of data. They want to be able to build models which are probability of a particular site getting damaged, time to go and make that inspection. So they have 10 or multiple different machine learning models, and they have a lot of scale, and they would rather use Abacus than not. So that would be our, I would say a sweet spot customer and a small to mid-sized company. Then we look at the Fortune 500s, and a few of them are actually our customers today. And a lot of them will go with either a use case which they haven't really worked on yet, and they want to, kind of build, do this end to end using Abacus. And then we also have something called Abacus.AI deconstructed. So for the people who have that 500-person machine learning team, take Pinterest, and Pinterest, of course, only uses AWS, as Dave mentioned. So we haven't really pitched to them. But if you have a 500-person data science team, what we can do is we can give you a module of our service as a standalone component. So let's say you had problems with data wrangling and data cleaning. We have something called a machine learning feature store that you can use, and that'll keep your data easy to manage while you can still.
What does that mean? Feature store is one of the hot topics in yes. machine learning. Do you want to define what that means?
Of course. So when you're building machine learning models, you have to build what are called features, typically. I mean, meaning the inputs that you send into your machine learning model are features, and they're usually coming from your raw data, right? Let's say you have a bunch of data, which is just data records. You want to be able to take that data, and you'll have to kind of transform it in a way that you can feed it to your machine learning model. The usual problem is, let's say you're someone like Pinterest. They have say millions, or even Netflix. They have millions of queries in a second, right? And so now we're talking about petabytes of data, and imagine transforming each petabyte of data even to compute, say, the average across 3 different points. Let's just assume that's a feature. A very simple feature could be the average length of a user session over the last 3 days. So let's say Matt used Netflix, and we want to know how long he spends on Netflix over the last 3 days, average length, that's it. But do that for billions of users that they have. That's a feature. And now, if you want to build this features, if you want to go build this model, a data scientist would have to go compute this feature on all of Netflix's customers almost in real time. It is super hard to do. So, there is the feature store, which helps you solve this problem. How do you do this? You basically specify your feature in the feature store. The feature store will then go to your data sources, batch your streaming, and start computing this for you and make it available for you for training or for real-time predictions, right? So that makes your model super simple. So now you can go literally build your model using a laptop if you want, and then you can go to the feature store, use an API, and get the data transformed. So now you don't have to deal with the data wrangling, the data cleaning, the data processing. You just use this feature store and you can get going. The other big advantage is, let's say I am a data scientist and I built this feature using this feature store interface, right? Now, let's say Matt comes along and says, I want to use that same feature, like the average session time of a Netflix user in the last 3 days in my model. Now he doesn't have to go build that feature all over again. He can just tag that feature, share it with me, and we're off to the races, right? So you're not wasting time data wrangling, and you're not making tons of copies of data. Hopefully that was,
Great. No, thank you. Super, super helpful. Okay. Very interesting. As I look at some of the questions, they actually interestingly correspond to some of your tweets, and I mentioned that I was going to ask you some questions about some of your best tweets. So here we are. So you had one that I thought was very interesting that said, startups often wait too long to train and deploy their first machine learning model. Your data is your leverage and your best moves against competition. Don't wait to hire a data science team. Use a Lowcode ML platform and get started ASAP. So you've seen people do this successfully, or how does one get started? I guess what are some examples of Lowcode ML platforms, and how do people go about doing that?
Well, it's a self-promotional tweet. So an example of a low-code ML platform would be Abacus. I mean, I'm sure there are others as well. I'll give you an example. One of our customers, a startup called Daily Look, they're kind of like Stitch Fix, except their business model is slightly different in the sense that I think you get to choose certain things that you want in your box. But presumably every month you get a box of clothing that you might like. You keep some, you return some. So, even when they were pretty small, they had a few thousand customers and they didn't have a machine learning team. They started using us and they've been using us for a year. They're one of our oldest customers. Now they're up to model 3 it's worked really well for them because they kind of knew what the problem was. They wanted to be able to optimize the amount of, the number of things that you kept every month, clearly, right? So you have to pick the right style items to send them on a monthly basis. Clearly, that's a machine learning problem. You don't have to wait until you have millions of data points. Even hundreds of thousands is too much. If you have 10,000 data points, that's my rule of thumb. If you have 10,000 data points, you're ready to build a model. The minute you build a model, you have what I call a virtuous feedback loop. So the minute now they have customers, they're using this machine learning model. And the machine learning model decides which items to send and which items not to send on a monthly basis based on that customer behavior. Now they spend less money, or they retain more of their customers. So their number of active customers or the monthly actives keep going up because the machine learning model is helping them find the right set of stuff to send so that churn is like very low, right? And so that's what startups don't do. They start with saying, hey, I don't have enough data for machine learning. I'm going to do a heuristic model. That heuristic model may not be perfect. It may not learn as the startup evolves. But if you start with machine learning from day one, you start kind of banking and becoming more and more kind of competition resistant to some extent.
Great. Among your many other good tweets, like another one I liked that was very sort of encouraging and inspiring, I guess. Becoming an expert at deep learning is largely about experimentation. Play with open source machine learning libraries, start with some simple CNNs on image data, try transformers and develop an intuition for them. You don't need to be a genius, just a tinkerer. And then you had a separate tweet that said, machine learning is like sex. The more you experiment with it, the better it gets.
Yes. Yes. Well, yeah.
So are you saying, so does one need to go to school and be trained, or is that something, basically what you're saying is you can train yourself to become a great machine learning engineer just by experimenting?
So, the truth of the matter is, if you think about it, when did deep learning start being taught in school, right? Less than some 10 years ago, very honestly. I mean, I don't even know if it was 10, maybe less than 6 years ago. So if we are, at least I graduated way before 10 years ago. Now, I think a lot of the people in the audience have, and some of the best deep learning engineers actually are people who have graduated over 10, 15 years ago. And the reason for that is they have experimented and they have thought themselves. And the idea is machine learning actually rewards the person who really is curious. And the curiosity, data exploration, and experimentation are the three, from curiosity, you want to explore, and from exploration, you want to experiment. If you have that mindset, you succeed in deep learning, especially. In fact, you can even write a paper, I think, and I've seen examples of this. You can actually be first or second author in a deep learning paper and submit and get that paper accepted at NeurIPS if you have that mindset. And there is also kind of intuition that you build the more you experiment. And there's so many courses and there's so many resources right now that it's actually not that difficult to get in and start thinking about it.
Great.
If you're interested, yeah.
All right, I'd love to switch to some questions from the group. We have some good ones. Let's see, one from Gedalia, who I think may have asked a question before this as well. What is the state of the art around labeling data? We really struggle with obtaining enough labeled training data.
Oh, it's a very good question. I mean, label data is really difficult. There's a whole company called Scale AI, which is, I think there's a bunch of companies around Scale AI too, which help you with labeling data. The good news is there are more and more models. And if you wait for 2 years, there'll be even more. But right now, even there are lots and lots of new models which are coming up, which don't require too much labeling. So take the best, most talked about one in the world, GPT-3. The whole reason GPT-3 is the most popular language model that is in the world today, or talked about most in the world, is because you need very little label data. So as an example, you can go you can give GPT-3 5 examples, and then it'll start learning very quickly. So, I think the state of the art is moving very rapidly, and so that you can teach models with less and less data. And this will be the case for both images and language very soon.
Question from Mark. What are some of the highest quality DNN models customers use? Example, BERT. I guess you.
Yeah, so BERT is a good one. We specialize in, in structured data models. So what we like a lot are deep learning based personalization models. They're super effective. They're also money making. Customers love making money, obviously. They also like increasing their revenue. So if you look at personalization, it's the single biggest revenue generator there is. And so basically by personalizing the experience of your customers, you can actually increase lift and engagement and conversion. And so these models, which are, they could be a simple RNN/LSTM models, but of late we've had a lot of success with transformers for personalization as well.
A question that is going to enable you to dish out on the competitors. What are some of your competitive advantages or even drawbacks compared to H2O.ai and Data Robot?
Yeah, so somebody actually knows our space, but H2O and Data Robot are really, maybe they consider themselves our competitors. We like to think of them as non-competitors. The reason for that is their real focus, as you probably may know, is on the auto ML or the automated machine learning part of it. Our focus really is to do that end-to-end. We've spent a ton of time in the data wrangling, data management, and doing that across multiple sources. So literally you can connect, your data from Snowflake, from Redshift, and from your data lake and Salesforce together and bring that all together. So I think our biggest competitive advantage is that data wrangling and the real-time feature store, which is part of our service.
Great. There was a question about how do you take outliers into consideration, I guess, in DNN?
Yeah, that's a good question. Outliers, you treat outliers differently based on the use case. Since we are use case aware, if you go to our site, you will see that we have these solutions like personalization versus forecasting. So with personalization, we just throw out the outliers. With forecasting, we keep the outliers and fill in missing values. So we do different data cleaning techniques almost based on what the use case is. And that's why we need to know what your use case is at some level.
Great. So maybe just to close, some quick sort of rapid fire bonus questions. Sure. What's your favorite data tool that you've been using over the years, like the thing you cannot live without?
I sound so self-promotional right now. Lately, I really started liking, okay, actually the thing I can't live without is Excel. It's a data tool, so I'm going to go with Excel. But then beyond that, I really, yesterday, for a fact, I trained 9 models and I was using Abacus and I liked it from the model training perspective. The other thing I think from a data science perspective, the thing which has really, really borne the test of time has been Spark.
What's your favorite data book, newsletter, or podcast outside of Abacus and the content that you guys create?
Podcast, newsletter. I love, the Freakonomics podcast. This is kind of more broader. I don't know if it's data driven as much, but, I think it's something which I really enjoy, especially when it comes to data trends that they talk about.
And last question. So outside of the immediate world of Abacus, what new data trend or product in the overall data ecosystem are you most excited about or most intrigued about? Any kind of new interesting thing that's come up on your radar in the last year?
So, I've heard of a company called Rockset. Actually, maybe Matt, you know more than this. But the thing that I'm most excited for is a replacement for Spark, which is easier. Something which, because Spark is very hard for like live queries. We've looked at different things, but there's a tool called Dagster you can look at. There's a tool called Rockset you can look at. But anything and everything which helps you do data transformations on large amounts of data in real time, I think is going to be the big thing. And sooner or later, we're going to figure something out there.
Wonderful. Well, that's a great place to end this conversation. Thank you so much. This was wonderful, really interesting. I really appreciate your spending the time explaining things to the audience as well. I'm sure people have gotten a lot of value, learning about those terms that like everybody hears about all the time, but like people may not have like an exact definition for it. So that was tremendous and very helpful. So thank you so much. And I guess we'll see you on the Clubhouse later tonight.
Oh, great. Thank you. Thanks for having me. Bye.
Thank you, Bindu.